Oh, did you follow me? Well, we can edit this out. But hi, I'm Tommy Ryan. This is my video lab for physics, for college physics lab. My experiment is a very simple one, as you were probably expecting from me, Dr. Martell. So, without further ado, let's get into explaining it. So, what I'm going to test is power. So, what power is equal to the work done over time. So, I'm going to be looking at the power generated when you're running up the stairs because you're 5 minutes late to physics lecture and you have to run up those flights of stairs. I'm going to calculate how much power is generated when we do that. So work over change in time. So work can also be quantified as the change in potential energy. And from physics we know that potential energy is the energy that an object has due to the force of gravity. So Ug is equal to mgh. So it's the mass of the object times the force of gravity times the height of the object from a standard. So if you could imagine me, I'm going to be at the bottom of the stairs, and I'm going to set this as 0. This is going to be my 0 for height. So my Ug here is going to be 0 mathematically, just because of the height. And it's going to start at t equals 0. And then I'm going to go up the stairs, and I don't know exactly how many stairs there are yet. And I will have a final potential energy that is equal to mgh, and time will be however long it took for me to get up there. And then from that I'm going to take this minus this, and that's going to give me work. I'm going to divide it by the time it takes for me to go up the stairs, and then I'm going to find out how much power I put into it. Alright, and here we are at the familiar stairs. So what I'm going to do is I have my handy dandy iPhone. I'm just going to measure the time it takes to go up these 12 stairs. Alright, Speed Racer finished it in 6.81 seconds. Yeah. So trial 2, I'm going to go a little bit faster. Going 2 steps at a time. And it took me 4.32 seconds. And last trial. 2.3 seconds. Alright, coming back from the stairs now with our data. So going off of, if we remember, it's mgh is where we're going to start. So we're going to start with my mass. I'm 163 pounds. I Googled it and I converted it to 73.35 kilograms. And then the force of gravity is a constant negative 9.8 meters per second squared force. And then the height is going to be the factor. So there were 12 stairs, 12 uniform stairs. Each stair was 18 centimeters tall. And that gives us 2.16 meters total. So that's going to be our H. So when you put it all together, it's going to be 73.35 kilograms times 9.8 meters per second squared times 2.16. And that's going to give you the total amount of work it takes to go up the stairs. So 1552.67 joules. And then you can calculate if you really wanted to. So it would be 1552.67 divided by 12 steps, and it's 129.4 joules in each step. And that could you just stop it now. Alright, welcome back from the stairs. So what we decided to do now is we decided to look at that number 1552. 1552.67 joules, and I completed my first trial in 6.81 seconds. And so if you do the math, it turns out to be 228.3 watts. My second trial was that same work total because I'm going at the same distance. It's just the time that's different. For the second one, it was a 4.32 run, and so I did 359.41 watts of power. And for the last one, 2.67 over 2.3 was the time. That gives me 675.07.